Hey guys, I'm Hero Serrano and I developed the Untold Engine and welcome to all of you that are joining my Twitch today. Um, what I want to do today is something a little bit different than what I've been doing for the past, I guess, a month that I've been on Twitch. So I was thinking how I can make my Twitch more entertaining. What I was doing was I basically was doing the normal stuff that everybody else is doing, which I think is completely fine. Which is basically go on Twitch and do live coding. But there were some problems with that I was experiencing with. Number one, I felt that when I would do live coding, I would actually slow down. Um, and I did see like how that affected my progress. And number two, I was asking myself, how entertaining is that, to you guys, to the viewers. So I decided to do something a little bit different this week, and uh, I didn't go on Twitch the whole week, and I didn't do that because my goal was like, why don't I just work throughout the whole week, and then on Sunday, today, I just give you a summary of what I did throughout the whole week. Um, and instead of doing, instead of you seeing me code, watching me code, I will just show you what I did and how I did it, and hopefully that will be more better use of your time. All right. So that's something that I'm going to start doing. I'm going to start experimenting doing that for the next month or so. So let's see how that goes. All right. Aside from that, I don't have any other announcements. Aside from the fact that if you are an indie game engine developer and you want to be part of a group, um, some indie game engine developers and myself, we started a Discord channel. So if you want to join us, the link should be on my Twitch panel information. So if you want to get some tips, get advice, get some guidance from other engine developers, join our channel. All right. Oh boy. Let's see. So, what else do I have to share with you? Not much aside from that. All right. So, let me show you what I did basically the whole month, right? So, I'm gonna go and share with you all of the issues that I fixed, that I implemented, and I'm gonna give you a brief summary, and then I'm gonna actually show you how, show you in the using the engine, the changes that I did. So the main things that I worked on was basically implementing array class that whose purpose is to find if the array is intersecting with a triangle or with axis aligned boundary box. I also implemented array cast class, like as you can see here, that one. Like I mentioned, I implemented array versus a box intersection. I implemented array cast class, and I will show you how I use that in the engine. And I also implemented a match data manager class, whose sole purpose is basically to build an org tree around a particular 3D model. And I will talk about that in a few minutes. Aside from that, I also noticed that I was having some issues with the motion of my camera. The motion was not smooth enough, so I had to add a particular I wouldn't call it interpolation. It's more like a weighted average type of equation that I added to it. So I fixed that, and I also was able to I was able to attach an external 3D model to follow the animation of another model. And again, I will show you that in a second, right? So those were the basic changes that I did. I think all of this took me about, overall, I think about a month or so. So yes, I was quite busy. Not as busy as I usually am. But you know, I was glad that I'm actually moving forward with all this. All right, so let me bring up the engine and let me go step by step what I did. All right, so number one, I'm going to build the engine right now, and I'm going to show you, what were my initial problems that I had, and then how I fixed them. So I'm going to build the engine right now, and I'm going to switch screens so you can actually see my Mac. Right now everything is building. And once it is built, I will show you. Should be loading, and there it is. All right, so here what I basically have is my the astronaut. It is carrying a pistol, and you're able to walk and everything. However, but let's say that if I want to go up the hill, one of the issues that you see is that the astronaut doesn't do that. It just goes through the hill, right? So I wanted to basically come up with a way of how to make it go up the hill, right? And to do that, I had to implement several classes, such as array class, array cast, and the mesh data manager. And let me explain to you how I use all of that. All right, so the whole idea basically, whenever you want a 3D model to go up a hill, up a slope, or down the slope, is the following. And before I move on, I do not know how they do it in other game engines, but this is how how it worked for me. And I think it works, so maybe they're also doing that. They're also doing it the same way. So the whole idea is this, right? Let's say you have your character, and you want to go up this hill or the slope, right? What I do is basically I should array from the center of the character, right? And going downwards, and I do an intersection test between the ray and the triangles making up this particular terrain in this case, right? So I do an intersection test between the ray that you see here and the faces that you see here, and these faces right here, right? And if there is an intersection, right, what I do, for example, let's say there's an intersection between the ray here, let's say that the character moves to the right, and there is an intersection between the ray and this particular face of the mesh, right? If there is an intersection, what I do, I get the normal vector of that triangle, and once I have the normal vector, I use that, and I get the direction of the character, in this case the red line here, and I do a bunch of linear algebra manipulation, such as I guess like the cross product, and on and on, and I change the orientation of the character, so that way the character starts to orient itself as if it's going up the slope, right? So that's the whole idea, right? And obviously to do that, I needed to implement array class. I needed to do a method that would actually test the intersection between the array and the triangle, and on and on. And actually, if you go to the engine, and if you go to the array class, which should be under here, ray.h, u4d ray.h, you will see that I have different functions, methods. do that test the intersection with a plane, intersection with a triangle or a face, intersection with a box, etc., right? So that's what I do. Now, there is a little problem though when you do this, right? If you have a small mesh, a mesh with a small number of triangles, this will work fine. There's no issue with that. However, the problem arises when you have a mesh with thousands of triangles. You do not want to literally search which triangle the array intersects, right? Here, if you count, I only have about 1, 2, 3, 4, 6 triangles to search, right? But let's say that you have something like this. Let me bring it up over here. Let me see if I can hide this so you can actually see it better. Right. So let's say you have like something like this, where your mesh has literally like thousands of triangles, right? It will be not efficient for you to do for you to search if your array hits every single triangle in that mesh. You need to come up with a more elegant way to do the search. So what I did, I implemented a mesh manager, right? And the mesh manager, basically what it does is let me go here. It creates an arc tree around the mesh, right? And an arc tree is basically you have a node and then you have like 8 children, right? And then you keep dividing each node into 8 smaller children, on and on and on, right? So here what I do, I basically surround or bound the whole mesh around my root node, and then I divide that node into 8 smaller meshes. And just for visual clarity, I'm not going to include all of the 8 nodes. I'm just going to include only one, but one of the nodes will be this one. And then I keep dividing that node into 8 smaller meshes. So the next one will be something like this, right? And then if you want to, you can stop here, but if you want to, you can keep dividing more and more. And I did that actually. And that would be actually that one right here, right? So the mesh manager divides the whole mesh into an arc tree. And then what it does, it basically, it assigns all of the triangles that are within the space of the smaller node, of the leaf node. It will assign it to be part of that node. For example, all of the triangles that are basically within the same space of the cube that you see will become I don't know if you can see it, but hopefully you can see it. This is the cube. So basically all of the I really want you to see this. Oh, I guess you can. Well, basically all of the triangles that are within the same space as the cube will be part of that leaf node. All right. So what I do then is something like this. What I do, let me bring up my triangle here, my mesh, and let me bring up my array. So now what I do, again, I have my character here, and then I shoot an array from the belly of the character going downwards. And the first thing that I do is I test, okay, is the array intersecting my root cube? In this case, it is, right? And then I go down the children of that cube. Keep in mind, I only have 8 to search, right? And then if I get an intersection with the array in the child cube, right, which will be this one in this case, then I will go down that branch and do a test with the smaller children, or the nodes of that cube, right? In this case, I will get intersection with this guy, and then finally I will get an intersection with that particular cube, right? Now you can see how I have reduced the amount of searches that I have to do when you do the search between the array and the triangles, because now once I get to this point, I only have to do a search with the triangles that are within this space, and that is it. And that could be 50 or 60 or however there are. So instead of me doing a search with all of this, all of these triangles, by using an octree, I have reduced it to just whatever are within the space of the smaller cube, which is the number that you see here. I don't know how many are there, but like 10, 15, whatever. So that obviously improves the whole efficiency of the search, right? So I did that by basically, implementing an array class, which does an intersection test between a triangle and an array. Also array with the AAB box. I also I implemented a mesh manager, which does the whole octree build up. And then I do a raycast, and the raycast class, basically what it does, it's very simple what I have right now for the raycast, but basically what it does the test between the array and the octree. That's how I have it right now. So basically the raycast tells the array, go to this octree and do the search, and if there's a particular intersection, return back the normal vector of the intersected triangle, right? So what that means is that if I go to the engine and I tell my plane, which in this case would be my terrain that I have here. Where are you at? This one. Which is this terrain that you see here. Let me see this. And I say, you know what? I want you to enable the mesh manager. What's going to happen is now that when I'm loading up the particular model, I'm gonna build an octree around it, right? And then when the character is actually walking around the terrain, it is actually shooting a ray to the going downwards through the terrain. And in this case, you can see it here, ray cast hit. And then I provide the array, I provide the plane, which in this case is my terrain model, and then I get back whatever triangle got intersected, right? And once I have that, what I do, I get a normal vector, and then I change the orientation of the character, on and on. So now that I have that enabled, let me show you how the character is able to go up the hill. So it's building right now. It should be up in a few seconds. All right. Come on. All right, so come back. All right, so now if I go up here and I'm ready to go up the hill, right, you can actually see that the character will start moving up. You see that? And it can also come down. So there you go. All right, so let me come back here. So that's what I did for for the ability for our characters to go up the hill. All what you need to do is basically enable a match manager and then do a ray cast between the character and the particular terrain in this case. Now, one of the things that I did notice was that when I was doing all of this, right, I wanted to obviously, change the camera perspective and see how cool it would look when you're moving around. So what I'm going to show you right now is I'm going to show you how I'm going to change between cameras, between the first person camera and the third person camera, and you're going to see a problem that I detected and why I had to actually implement a kind of interpolation for the camera movement. Just let me make sure. So when I press the button X, I'm going to go to first person camera, and when I press the button B, third person. All right, so I'm going to run this again, and I'm going to change the camera that I'm using. All right, so you see that. So I'm going to press B, and that now I'm actually using my third person camera. All right, now what I'm going to do, I'm going to actually change to first person camera, and you're going to see a problem with this, right? So now if I want to go up the hill, you're going to see how the motion of the camera is not smooth enough. Let me bring it back. You see that? It's a little bit like I don't even know how to describe that, but very primitive movement, right? So you may think, how can I say this? The fix is actually very simple, right? And at first I thought that if I just use interpolation, everything would be fixed. The problem with that is that if there is a huge change between the direction of the camera, the interpolation doesn't really do much. It doesn't really help at all. All right. So what I found out, and let me bring this up because I will want to read this for you. That instead of using interpolation, you should use something called the recency weighted average. And basically the whole equation is this, or formula is this. You have your recency weighted average, and you provide a bias, right? And you multiply that bias times your weighted average, and then you add that to 1 minus bias times the new value, right? So in this case, my new value would be my view direction of the camera. And what happens is that when you use this recency weighted average, what it does is this: it keeps an average of the last few values, with more recent values being more significant. The bias parameter controls how much significance is given to the previous value. A bias of 0 makes the weighted average equal to the new value each time it is updated. That is, no average at all. And a bias of 1 ignores the new values altogether. All right. So what you need to find is the perfect point that will make the whole that will take the average of the previous values that you want and the new ones and the new value that you want. You need to find the perfect I'll say like intersection point, right? In this case, for my first person camera, I found it to be 0.98. All right. So when I add this, what happens is that motion accumulator, right? I'm gonna build this, and then I'm gonna go back to the camera, so you see how that changed. Basically, this is my recency weighted average. I have an accumulator. Basically, I have the accumulator, and then the accumulator, I multiply it times my bias. Then I add the new value, which is my view direction of the camera, times 1 minus my bias. And will give me a weighted average for the camera movement. All right, so let me go back and I'm gonna run this again. All right, so now it's building. And I'm gonna change it to my Mac. Can you see my Mac? Oh, there you go. All right. So let me go back. This is first person, third person camera. Let me just get closer to here. Okay, so now I'm gonna change this to my first person camera. All right. So now you're gonna see that when I go up the hill, the whole movement of the camera is a lot smoother. You see that? Let me do that again. So it doesn't do the whole jump as it was doing before, and that's what I wanted to fix. Although there's a little bit of problem there, but let me go here. Oh, there's a tree right there. Let me go up that hill right there. Now when I go up to that one, everything is a lot smoother. You see? Let me go to this hill right here so you can actually see that. You see? And I can come back. And I think the problem that you think the flickering that you see here when you go up is that I have the camera way too close to the mountain, so that's why you see that. Actually, let me see if I can go back a little bit back. Third person camera. Let's see if I bring it to 4, would that help? All right, everything's built in. I hope that me bringing it down backwards to 0.4 actually is not going to hide the whole. All right, so X. All right, let's see. Let's do this one more time. I'm going up the hill. And there you go. Still see the flickering, but I think it's the camera just being too close. I have to double check on that, but regardless, you can see actually how the camera now, the whole motion is more smoother and everything. But I will make a note of that. I wonder if the problem is with my character being way too close to this. Let me bring this down a little bit. That may be the problem actually. I'm sorry, I have to double check that I don't have any further issues with this. So. All right, let's build this again. And all right, change it to X, to first person camera, and let's do this again. Hopefully I don't get the blackage. I still see the blackage. I wonder why. Alright, yep, I'm blocking the camera with my movement. That is weird. Alright, I will have to fix that, but the whole point is that now that I'm able to go up, you know, the fact that I actually move my my camera to 0.4 actually is affecting it. Let me go back to 0.5. Let me build that again. I will double check on that. I did a test with other terrains and it worked fine. So I hope it's not something. I hope it's the geometry of the terrain that is causing that issue. And if not, well, I will have to fix it. Okay, boom, 0.4 my camera. Let's do this again. All right. Let me go up this hill. Yeah, I have to figure out what's going on. Let me see if I go actually to the side of the hill. Let me see. Yeah, the motion is here. I think it's the slope of the particular mountain that is blocking the whole view of the camera. So I'll have to fix that. And here I went down. I actually went below the whole thing. All right, I'll fix that later. All right. Then the third thing that I did was basically I wanted the pistol that you see here, right, to actually be able to move along the motion of the armature of my character. And if you know, the armature and the bones of the armature are basically what control the animation of the character. So what I wanted to do was it was to attach this the pistol, and I wanted it to follow the movement of the astronaut. And as you can see here, if I show you, I'm gonna bring it back the whole engine so you can see that the pistol doesn't follow the animation at all. And funny thing, I thought that problem was going to take me a long time. You see that it doesn't follow. You see how it doesn't actually follow the movement of the hand of the character, right? So I wanted to fix that, and I was thinking, you know, how in the world can I actually make the motion, you know, better, nicer? So what I did was the following, and to be honest with you, I thought it was going to take me a long time to fix, and it didn't, right? So let me just let me copy this pistol and let me bring my walking animation so you can see what I mean. Okay, so that's my pistol right there, and let me get my animation here. All right, so basically, like I mentioned, when the bones move, right, I want the pistol to also follow the same movement, right? In this case, what I want the pistol to follow the movement of this particular bone right here, which is called the name of that bone is actually called hand.r, right? Like hand dot and then right, meaning the right hand, right? So, but how can you actually do that, right? And I was afraid this was going to take me a whole month to figure it out, because I do recall when I was doing the whole animation, when I was implementing the whole animation system, that was a little bit of a headache. So luckily, it didn't even take me not even half an hour. And not because I knew what I was doing, I was actually just experimenting, like trying to get a sense of what should I change or what I should not change. And through my experimentation, I came across the solution, which was like, okay, well, I guess this is all what I have to do, right? So basically, um, this is what I have, what you need to do. In your animation, here, you have two positions, right? Or a space matrix, right? You have your rest position, right, which is the armature itself, right? And then you have your animation space position, right? And all what you need to do is you need to compute that particular space during the animation. That's all what you have to do. And if you go to the folder objects and you go to body objects and then go to game objects, that is exactly what I do. Number one, what I do, I get that the bone rest position, right? And the bone rest position is basically when there's no animation at all, right? So when I add the pistol, which is the gun here, right? I create the gun here. And when I add the pistol as the child of my astronaut, right? I compute that particular space, get bone rest pose space, right? And I'm gonna get a matrix, a 4x4 matrix, and then I set the location of the gun to that particular matrix. So basically, when it starts off, the gun itself will translate to this position, to the position of that hand.r, which is this guy, and which I specify here, hand.r, right? And that only works when there is no animation, right? The bone rest position. Now, when there is an animation, now I need to get the animation bone position, and that is a little bit different. Here I get the get bone animation pose, and again, number one, I check if the animation is playing, because you're gonna get an error if there's no animation present. So I get the animation bone space and I do a bunch of calculations, not a lot actually. Or basically I just get the final space matrix and the animation pose space, and I do simple computations actually, to be honest with you. And when the character is actually animating, right? In this case, when it is walking, I want to uncomment this. I get that bone animation pose for that particular hand, right? And I get a matrix, and then I apply that matrix to my gun, to my pistol. And the same token is when I'm about to start shooting, right? Which you will see in a second. I just change the particular matrix for the gun, and that's all what I basically do, right? So now when I run this, and let me run this again. You are going to see what I mean. So it's building. Alright, so you see that. Let me go to this. Now when you see now when I walk, you see how the character follows the whole how the gun actually follows the hand movement, right? And not only that, so now if I want to shoot, you're gonna see how the hand moves, and the gun also moves along with it. Again, I thought that was gonna take me a long time to figure it out, and actually it didn't. So that was kind of cool. So I can actually go there, and you see it there. I can actually go here and I can shoot it, you can see the bullet actually going that way, right? Um, so that's basically what I implemented, right? And now, um, as you can see now, here I'm actually running, I'm seeing the whole view through the third person camera. And again, the third person camera also uses a recency weighted average. So that way when I go up the hill, everything looks smoother, um, and not as too choppy as it was before, right? You know, here I have my basic follow camera, which I can come down, and then I can change to my first person camera. Where am I at? And here I can come here. If I can go up the here, and boom, that the gun follows the hand of the particular character, and when I'm ready, I just shoot. You know, boom. And there you have it. So that's all what I worked on during the whole month of I guess half of March and April. So now my next plans are, number one, I have to double check on why there is a particular glitch when I go up the hill with the camera. I honestly can tell you is the geometry of the hill or the position of the camera, because I did test it with other terrains and everything looks smooth and everything. And I also believe I have a prior Twitch that I did that shows that, but I have to double check just to make sure that there's no problems. Then so my next, what I want to add next to the engine is actually add kind of a artificial intelligence system, right? And it's not going to be too complicated. I'm going to start very small. I want to add a navigation mesh to it, and I want to add the normal components in an artificial intelligence, such as the um, what are those names? Flee, find. No, it's not fine. Flee, seek, evade, stuff like that. Simple implementations to that. And I think that the hardest one of all as of now, and I've been researching on that actually. I was actually reading that last night, and it is this here. I was reading this article here on how to compute or create a navigation mesh. Is it this one? Let me bring it up. Yeah, I was reading this article right here. So I will be working on this, creating a navigation mesh, and adding some AI implementations to the engine. Aside from that, guys, like I mentioned, I'm going to try not to go on Twitch for the whole week. I actually do like going on Twitch, to be honest with you, but I do not know if this is interesting enough for you. I don't know if watching me code is interesting enough for viewers like you to stick around for an hour or so. So I want to make it more entertaining and more interesting. So I'm gonna go live again, hopefully by next Sunday, if I can, if I don't get the urge to go on Twitch sooner than that. Aside from that, guys, thank you for joining my Twitch. I hope I hope you learned something, and I'll see you next Sunday. So thank you.